Okay. So when we have area and volume of similar shapes, so what that means is that we want to compare the area of similar shapes. I want to compare the volume of solids, similar solids as well. Now, we talk about ratio of corresponding size. For example, if this is A, this is B, this is C, this one is X, this is Y, and this is Z. So the ratio of corresponding size now. So AB corresponds to, okay, let's say we have this here. We have this one to be 2, this one to be 2. All right. So AB corresponds to XY. Then AC corresponds to XZ and equals to BC corresponds to YZ, right? Now, if AB is given to be 2 and this is 4, so which means the scale factor for this similar shape is 2 AB over XY, which is 4, and that's going to give us 1 over 2. This is what we call scale factor. So to now get the area factor.
That which one? What's K factor?
Okay, good. You know, similar shape is the same thing as enlargement.
Okay.
The same thing as enlargement. So I'm coming. Let me clean this side so that we clean it better. So this triangle ABC and triangle XYZ. Triangle XYZ is an enlargement of triangle ABC. That's the meaning. That's the meaning. Similar shapes. The bigger one is the enlargement of the smaller one. So we now want to look at what
Okay.
is the scale factor of the enlargement. By what? For example, now if you look at this AB, to get corresponding side of it, when you multiply it by 2, that means you're going to get 4. So if this is 2, if this side is 2, to get YZ is going to be 6. And if this is,
Okay.
let's say 4, this one will be what? 8.
8.
So the scale factor used there is 1 over 2 or 2, because if you take the corresponding side of AB over XY, it's going to give us 2 over 4, and that gives us 1 over 2. Which is the same thing as writing it to be 2 over 1. When you flip this XY over AB, so that means we are saying 4 over 2 is equal to what? 2 over 1. That's equal to 2. That is, to get the enlargement, the scale factor used to enlarge this triangle is 2. So one a side is given, you can know the rest of the other side. So that is what this one is all about. But that is not where we're going. Where we are going is that we want to look at when you are given a scale factor, linear factor. Scale factor is also known as linear factor. Linear factor. So linear in the sense that we are looking at using the size to determine the factor of enlargement. So in that case, for us to now get area factor now, that's where we're going. Area factor is equal to linear factor squared. Linear factor, everything raised to power what? 2. So if you are given that example now, let's start example. Given that the corresponding size, even that the ratio, let me put that way, this is how it's going to come.
Sorry,
You,
sorry.
yeah,
That
I'm
linear factor you're talking about, where did it come out from again?
okay. It's the ratio of corresponding size.
Okay, ratio of corresponding sides.
Right. It's also known as linear factor. It's the same thing as K factor. The
Okay.
same thing as K factor or linear factor. We are saying the same thing.
Okay.
Uh-huh.
Okay.
So
Okay.
if we now want to find area factor, you are just going to square the linear factor. So to get area factor, square the linear factor. That is the formula. This is the formula we're going to use. So let's now look at example now. Given that the given that the ratio of corresponding size of a similar shape is 2 to 5. Find the area factor. So what this means is that you have been given this one, the ratio is 2 to 5. When you are writing ratio, you can write it in form of fraction. So this 2
Mm-hmm.
ratio 5, the same thing as saying 2 over 5. So that is linear factor, corresponding size. So linear factor here is 2 ratio 5, which is equal to 2 over 5. Are you there? Are you there? Hello?
Yes.
Okay, good. So,
Yes, I'm with you.
okay, good. So the question asks us to find the area factor. We are looking for the area factor. So area factor now is equal to the linear factor, which is 2 ratio 5 squared. That is going to be 2 squared to 5 squared. That's going to be 4 ratio 25. 4 ratio 25. That is one aspect of it. And another aspect, okay, before that, so what is the area factor of a similar shape with ratio of corresponding sides of 5 to 7? So 5 to 7, what's going to be the answer? This is linear factor. What's area factor? No, 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 no. That's not mine. Mm, okay, okay. So area factor. What's going to be the area factor here?
25 ratio 49.
That's good. 25 ratio 49. We have a lot of these in BEC, NECO BEC for GS3. They have so many questions on this. Now let's now um, look for another aspect of it. That is one, two. So if the linear factor of similar triangles is 2 to 5. If the larger triangle, if the area, sorry, if the area of the larger triangle is 42 centimeters squares, find the area of the smaller triangle. Find the area of the smaller triangle. Find the area of the smaller triangle. Now, we have been given the linear factor. That is the ratio of corresponding side, which is what? 2. Solution now will be 2 over 5. Now, for us to now get the area factor, this is linear factor now. Linear factor is 2 to 5. Let me write it properly so I can get it. So linear factor is 2 to 5. Now, We need to get the area factor because they are telling us the area of the larger triangle and we are looking for the area of the smaller triangle. So area factor, we need to change this one to area factor first. So to do that, so that means we're going to square 2 squared all over 5 squared. That's going to give us 4 over 25. So now this is now area. So we're now going to equate it. That's going to be 4 over 25 equals to, so from 4 and 25, which one is bigger? Between 4 and 25, which one is bigger?
25.
25. Now, the area of the bigger triangle is given to be 42. So which means going to be equals to 42 here. 42 be the bigger one. Then the smaller one will be x. The smaller,
I don't know. I don't know if the problem. Sorry, I don't know
okay,
if the problem is from my area. Your
okay,
voice is fluctuating. At times it will be slow. At times it will be loud. I don't know why.
okay, I'm coming. I'm coming. Then how about now?
Yes, it's loud now.
It's better, right?
Yes.
Okay, good. Sorry for that. I have to change the device, this the earpiece I'm using. All right. So thank you for
Oh,
letting me know on time. So okay, let me clean this so that I can re-explain this side. All right. So now that
all right.
we have known the area factor to be 4 over 25. Now, so we are looking for the area of the smaller triangle. So we just say let the area of the smaller triangle be x. All right. So we have been given the area of the bigger triangle to be 40, 40 what? 42. So that's going to be x all over 42. Now we have converted this linear factor to area factor, which is 4 over 25. So this would then be equals to 4 over 25. From here now we're going to find the value of x. So we can cross multiply, and that's going to be 25x. Can you hear me?
Yes, I can hear you.
All right, that's good. So that is x times 25, then 42 times 4. So from here now, we can have 25x equals to 100 and so this is going to be 8, 168. Divide both sides by 25 by 25. So this cancel this. So the area x will then be 168 divided by 25, and let's say 168 divided by 25, and that gives 6.72 6.72 centimeters square. That means the area of the smaller shape of the smaller shape is 6.72 centimeters squared. that is that on this one. Is it clear? Is it clear? Because I'll give you question now. So hello, I'm talking to you, please. Hello.
I can hear you. Don't give me question, no.
No. I will give you
Ah,
just one question, just one. Don't worry, I will guide you. Just one question. So that will make me to know that is well understood by you. Okay. So the question is,
okay.
don't worry, we do it together. two similar, this is a question, two similar triangles have corresponding size of 6 centimeters and 10 centimeters. If the area of the larger, if the area of the larger triangle is 60 centimeters squared, what is the area of the smaller triangle? Okay, so that is the question. So before you attend the question, I will stroll off for you to just go through what we did. Let's go through it together. So this is it. The question: if linear factor of similar triangles, that is the ratio of corresponding size, is 2 to 5, and the area of the larger triangle is given to be this, find
42
the area
centimeters square.
of the smaller triangle. So to now solve that, linear factor, which is 2 over 5, then you need to change that.
Mm-hmm.
So since it is area we are looking for, we need to change it to area factor. So that means we are going to square the linear factor.
Okay.
So once you square this linear factor, you get 4 over 25. So having known that, we have been given the area of the bigger one. So let's represent the area of the smaller one to be x. So since 4 over 5 is now area, we can then say that x, which is the smaller one, because 4 is smaller than 25, all over the area of the bigger one, which is 42. Then from here, we have equation involving fractions. We cross multiply, then find the value of our x, and that means the area of the smaller shape is 6.72 centimeters. I hope that is clear. So
I think so.
I think so. Okay. Now look at this question and see how you can try it.
Zero smaller. Okay. X over 60 equal to 36 over 100. X 100 x equal to
Mm. All right. Uh, so let's stop the recording.